sometimes they order coverage orders with standing orders. So this would be an example of a coverage order. So what does it mean, coverage order? It means I have to do something and cover it with insulin. And that something I do is check their finger stick. So give Humulin R based on the finger stick. So at 12 o'clock, the patient's finger stick was 149.
You give none.
Here's the coverage order. These are the parameters. So
No.
all I have to do is what? Where does 149 fall on this parameter list?
Less than 150, no insulin.
So I don't give any insulin because maybe this patient at 149, maybe their sugar drops too low. So how much insulin will the nurse administer to the patient?
None.
None. It's not a trick. None. So in this example, you're going to give no insulin. Okay. Now let's combine the two. What's that?
Just write no, not zero.
Yeah, you can write 0. I would accept 0 insulin. Okay. Now tell me what the answer to this one is.
Ten units.
10 units.
Okay. So the sugar was 348. I look at the scale, that falls here. So what is the total amount of insulin I'm going to give my patient? I'm going to give 10 units. Okay. Now let's see what it means when we combine the two. And these are the type of orders you will see when you're practicing in the hospital setting, majority of the time. So the first part is the standard order. The doctor says give 13 units of N mixed with 11 units of R before meals and at bedtime. So let's say 2100 is the bedtime. You check the sugar and it's 202. 202 falls where?
6 units.
6 units.
So what's the total amount of insulin?
Give 30.
13 plus 11 plus 6 is 30.
30 units.
So the final answer is 30 units. So you basically just have to be aware of how to identify the standing order and the coverage order. And for fundamentals and calculations, I'm not going to trick you and say, it's really breakfast, but it's not breakfast. And I'm not going to use that. No. When you're practicing as a nurse, you need to know when AC and HS is. Because if the doctor orders insulin and you give it and it's 3 o'clock in the afternoon, it has nothing to do with a meal or bedtime, you've made the error, not the doctor. You know what I mean? So this is a basic insulin order. So tell me what your final answer is for this.
$22 units.
Okay.
22 units.
So I'm seeing the answer. Yep. Good. So when you find yourself struggling, just bring it back to the basics. Go through it. 7, 5, AC and HS. Oh, a coverage. It was 303. 303 falls here. So now I have to go 7 plus 5 plus 10. And don't forget to write units. Insulin is only given in units. If you gave 22 milliliters, you will kill your patient. Insulin only in units. That's why the unit of measure matters. All right. You feeling good about it?
Yes.
Me too. Me too. Let's talk about feeding our patients when they can't swallow and take food through their mouth.
Uh-oh.
I know, right? Why didn't you get your blood pressure fixed, Ethel? All right. So what happens? These patients, for whatever reason, usually a stroke, they can't swallow safely. And when they swallow food or drink liquids, it goes into their lungs. So now we can't feed them through their mouth. So we put a tube in their nose or in their stomach. You'll learn about that in 118 and 116. But in the meantime, while we're waiting for surgery, we got to feed them something, right? I don't want to starve my patient. So we give them enteral feeding through the tube in their nose. But whatever they have, we have to be able to figure out how to administer this feeding. So doctors will write orders. You don't see this too often anymore, but it still happens. So we want to make sure you understand the process. So doctors will write orders to dilute the feeding. So this is just one example of what a feeding would be. So this is a liquid formula, kind of like baby formula if you think about it, but it's for adults. It has high calorie, high fat content, or maybe it has low protein. It all depends on the patient's condition. So patients who are dialysis, whose kidneys don't work, they have special formula for low protein kidney dialysis patients. They have formulas that are for blood sugar, like Glucerna. They have formulas with high protein, low sugar, high fat and lipids. There's so many things you can give, and that's part of the doctor's orders. But as a nurse, if the doctor needs to dilute it, you need to know how to figure that out. And why would we dilute a feeding? Because the feedings are so rich and thick. When we start to introduce it to our patients, they can sometimes start vomiting, which could put them at risk for the vomit going into their lungs, or they can get severe diarrhea. With that being said, we're only going to ask you to dilute in one way, and that's by half strength or 50%. So you'll see a question similar to this. The doctor says to dilute this feeding by half strength formula. The formula comes in a can. Here's the can. And in this can, there's a total of 250 milliliters of formula. So I'm just going to write this, 250 milliliters of formula. So how much water does the nurse need to add? I see you, CC. How much water does the nurse need to add to dilute it to half strength?
250 ml.
So how much water?
Water.
I heard it.
250 ml.
Oh, I have to add 250 mLs to dilute it by half. And that's the answer. So the answer to this question, how much water will the nurse add, is 250 mLs. Oops. 250 milliliters. That's it. So some students are like, wait, how do they get water into this can? We don't put it in the can. We actually get an empty bag. We add the formula, and then we'll add the formula, and then we'll add the water and mix it in this bag. And that's half strength. All right. Now, remember, feeding is part of intake and output in the body. We're giving them fluids in the body. Just keep that in mind. So now, what's the answer to this question?
It's not the same, 350 milliliters?
350
It
milliliters.
is the same, yes.
350,
Yes.
right, 350.
Right.
I don't know, it was
If I
worded
go in-
different. I was
if-
like, wait, she
No,
moved the
no, see, you guys,
sentences all over
everybody's
the
always
place.
assuming you're trying to trick me. No, I ain't got time for that. Yeah, you go into the pantry, and in the pantry, there's a can that you need that's 350 milliliters. I have to dilute it by half. 50% is half. So if I have to dilute it by half, I have to add equal parts water. And that's 350 milliliters. So the answer to this question is 350 milliliters. And you're thinking that can't be that easy. But what if I asked you, what is the total volume the patient received? Ooh, you got it, Stacy.
700.
That's right. If I had 350 milliliters of formula and I added 350 milliliters of water, that's the total the patient got. So the total volume is 700 milliliters. And this is what we're putting on our intake. Always. So the only way you're going to be asked about feeding is either I'm going to ask you how many milliliters you're going to add to dilute it, or I'm going to ask you the total volume, one or the other. So now this one, You think I'm going to give it to you in milliliters? No. No, I need to know you know how to convert. So now, what about this one? You go into the pantry and you have to get glucerna, and all they have is a 10-ounce can of glucerna. Now, to make that half strength, I have to add equal parts water, right? So that's 10 ounces of water. Do you all agree with me right there? Right?
Yes.
But what's the rule about intake and output? I need to know how many
It's in
milliliters.
milliliters.
Right.
Milliliters.
So it's asking you how many milliliters of water. Well, if I have 10 ounces of water, I just have to convert 10 ounces to milliliters. So how do I do that? The way I just learned 20 minutes ago, using dimensional analysis, or you can just show me 10 times 30. So how do I use dimensional analysis? I know that the given is 10 ounces. My wanted is milliliters. And I don't know that 1 ounce is 30 milliliters. So 10 times 30,
300.
300 milliliters. What's the total volume?
600.
600. But this question only wants to know how much water. Okay, do this one. All right. So you go into the pantry and there is an 8-ounce can of Jevity. And you know to dilute it, you need to add equal parts water, 8 ounces of water. But the question wants to know the total volume. Well, the total volume, 8 and 8 is 16 ounces. But I know as part of intake and output, I have to automatically convert it to milliliters. So now my given is 16 ounces and my wanted is milliliters. Let's just go through it. How do I get rid of ounces to milliliters? 1 ounce
30.
is 30 milliliters. And that leaves me with milliliters in the numerator. So 16 times 30 is 480 milliliters total volume. All right, so that's how you do feeding. You just need to know equal parts water and convert it to milliliters. And you just have to read the question. Am I asking you for how many milliliters of water, or am I asking you total volume?
Total volume.
Professor, could
Okay.
you just multiply by 30 and then times it by 2? Like 8 times 30 and by
Yeah,
2?
just show me your work.
Okay, cool.
Yeah, absolutely.
All right, thank you.
All right. And this is just another example that we don't need to do. It's obvious it's the same setup. You go into the pantry, it's 6 ounces. You have to add 6 ounces to make it half strength. So what's the total volume? 6 and 6 is 12. 12 times 30 is 360. It's the same setup. And that's what I mean by practicing over and over. It'll become muscle memory. But what you all have to get comfortable with is really taking the time to read your questions. So right now, you've just earned 15 points on your exam. You know how to do intake and output, insulin, and feeding. All right. So make sure you read the questions. Now let's talk about capsules and tablets. So this is what a capsule looks like. Can anybody tell me what's important to know about a capsule when you're solving for your answer?
It can't be split.
I can't split a capsule. So that means the final answer has to be a whole number. Okay? I can't have a capsule and my final answer be 1.25. Okay? There's no way to do that. So our rounding rules are capsules are whole number. Okay. And if for those of you that work places where you split capsules, that's great. You open them up and do, I don't want to know. That's not the RCC way. You got to just do it our way for now. Okay. All right. So let's go to it. The doctor says, I want you to give 375 milligrams of whatever drug this is. You go into your pharmacy med cart and you open the drawer, and in there is a package with a little pill, with a little capsule in it. And on it, it says every capsule has 250 milligrams in it. How many capsules will you give as the nurse? Let's do it the dimensional analysis way. Now, how about I give you a minute to try to solve it? Let me do that. All right, so I've got a couple of answers that are good. I love it. So let's do it together. All right. So in this question, what is my given? Does anybody know how to know the given?
You mean what the doctor prescribed?
Given is 250.
Yeah.
What the doctor prescribed.
What the doctor
375
prescribed,
What the
375.
doctor, yes, very good. What the doctor prescribes is the given. So the doctor prescribes. So in a question, you may see the doctor orders, the doctor prescribed, the PCP, the NP, but you have to look for those words. That's right, Ghislaine, good. You have to look for those words to find out what is actually ordered, and that's what our given is. So the doctor orders or prescribed is 375 milligrams. My wanted, what do I want? The wanted in this question is, what am I going to give my patient? Am I going to give my patient a
Capsules.
turtle? No, I'm going to give them capsules because that's how it comes. So my wanted is capsule. So my path is I got to figure out, there's really not a path because I don't need any conversions, because what's available to me is milligrams, and what I need is in milligrams. So I start with my given, 375 milligrams, and I put it over 1. My wanted is, what am I going to give my patient? And that's capsule. And I'm going to put that over 1. So now I need the word capsule in the numerator. And this is what dimensional analysis is. It's eliminating and getting to the unit of measure. So how do I get rid of milligram?
1 cap over 250 milligrams.
Right on. And that's what we call what's available on hand. And available and on hand is 1 capsule is 250 milligrams. So that's what we're going to use. 1 cap is 250 milligrams. When I write it like this, not so sloppy, but when I write it like this, I eliminate the milligrams and I'm left with capsule. So now it's just math. So 1 times 250 is 250. 1 times 375 is 375. When I divide 250 into 375, unfortunately, my calculator says 1.5. But what's the rule with the capsule? I have to make a decision. Either I'm going to give 1 capsule or I'm going to give 2 capsules. 1.5 is right in the middle, right? But what's that rounding rule? 5 and up, I round up.
The 2.
So I'm going to give 2 capsules. Now,
Professor?
Yep.
I definitely used to overthink this question. I've seen it before.
Yeah.
Because I was thinking, like, aren't you overdosing this a little bit?
Yeah, listen, this isn't we're not, if this was in real practice, you would be like, yo, doc, you got to look at these doses. Something's wrong.
Okay, so then I wasn't bugging
Yeah,
out. So
no,
I
you're
was
not bugging
thinking,
out.
like, this is a little
Yeah, no.
overdosing.
This is just purely so I can incorporate rounding with knowing that capsules can't be split. That's all. Yeah, no, in real practice, you would be like, doctor, like you're off by like half a strength in this medication. Do you want to change it? Do you want to look at it? Definitely. You're not thinking crazy, but just for calculation purposes, you need to know I have to round it following the rules to 2. That's it. All right, now here's an example of a tablet. So this tablet is scored in half. It has this little perforation, and all that means is I can break it along that line. So if I can break it along that line, that means I can give just a half of a tablet. I can give an entire tablet. It's just breakable if I need to break it, because every patient could be on different doses of a certain med. So they try to make them as available without having to manufacture like 1,000 more of the whole tablet, and then I have to generate 1,000 more of a half a tablet. So it's just the way that we can alter and change doses using the same medication. So when I look at this, it says from 1 gram tablets, prepare 1,500 milligrams. How many tablets will the nurse give? So what's my given in this question? What is the given?
1,500.
Right. Prepare 1,500 milligrams. And what is my wanted?
Tablets.
Tablets. I'm going to give what's available. It's a tablet. I have no unit path and no conversions. What's available to me?
One tablets that are 1 gram scored.
So I do need a conversion. What's my conversion I need?
1,000 milligrams to 1 gram.
So I do need a path, grams to milligrams, because what's available is different from what is ordered. And that's why I need to know my conversions. So we start with the given. My wanted tablets. And this tablet happens to be scored. So now it's a process of elimination. How do I get rid of milligrams? What do I put here in this fraction?
1,000 milligrams is the denominator. 1 gram is the numerator.
All right, beautiful. When I do that, I cross off my milligrams. Now I have grams to get rid of. How do I get rid of the grams? Because I only need tablet. So I
Is
use
it
this.
tab?
I've used this. I heard it.
1 tab over 1 gram.
You got it. And now it's just math. So 1 times 1,000 times 1 is 1,000. And 1,500 times 1 is 1,500. So now I have to divide 1,000 into 1,500. And what will my calculator say?
1.5.
1.5. Hold on one second. Sorry. Oops, give me 1 second. I'm sorry. Something just popped up. Oh, shoot. Okay, so my final answer on my calculator will be 1.5. Do I need to round that? Can I give 1.5 tablets when it's scored in half?
Yes.
Yes.
Yes. So that's my answer. 1.5 tablets. Now you can write tab or tabs or tablets out. All right. Or you can write it as 1.5 tablets. I will accept that as well. Okay. Good. Now here's one. And now this one can be split into quarters. So that means if I have a pill that can be split into quarters, I can give a quarter. I can give a half. I can give 3/4. I can even give a whole pill. So I have so many more options, right? So that means I have to really pay attention to my final answer and if I have to round it. So what is my given in this question?
0.75 milligrams of
0.7.
Synthroid.
That's right, 0.75 milligrams of Synthroid. My wanted is tablets because that's what I'm going to give my patient. Now, do I need a unit path? Because what's available?
Yes.
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 Milligrams to microgram.
That's right. 250 micrograms per tablet. So I need to go milligrams to micrograms. So that means 1 milligram is 1,000 micrograms. So now I'm going to pause it and I want you to solve this. No pressure. You're just administering a med to a patient. You could be off by 1,000. All right, go ahead and solve. All right, so my given is to prepare 1,600 milligrams. Oops. My wanted is I have tablets that's available to me and I have to give tablets. And this is very important to remember when I say, what is the wanted? It means what are we going to actually give the patient? Now, do I need a unit path? Well, what's available is 3.2 grams per tablet. I know, wacky numbers. It's just to test your math. All right, so I do need a conversion. I need to know how to get grams to milligrams. So 1 gram is 1,000 milligrams. So I can work with that, no problem. So I start with, what is with my pen? I start with the doctor's order and I know where I'm going, I need tablets. And these tablets can be scored in quarters. Beautiful. Or halves or whatever I need. So I have to start eliminating. How do I get rid of milligrams? Well, I have to use what's available to me. So I know where I'm going. I know that I need this conversion. So the first step is I can use my conversion to get rid of milligrams. 1 gram is 1,000 milligrams. Beautiful. And you'll see me crossing off what I've used a lot. And then how now do I get rid of my grams? Well, what's available? And that leaves me only tablets as my unit of measure in the numerator position. So now it's math. So when I multiply across the top, it's 1,600. When I multiply across the bottom, it is 3,200. When I divide into it, I'm going to spot check myself to make sure. And my calculator tells me the final answer is 0.5. So what will I write on my answer line? Just 0.5 tablets, or I can write half a tablet. That means I will literally split this in half and just give the patient 1/2 the tablet. So in a cup, I'm just going to give them a half of a tablet. And that half of a tablet has 1,600 milligrams in it. That's why we're doing this, to make sure we're giving the proper dose to the patient, the proper strength. Okay? Cool. So the next thing I want to talk about is reconstitution. So that's tablets and capsules. You obviously will see that. Now, the next thing is reconstitution, or not reconstitution. That's not yet. So we were dealing with capsules and tablets. Now we're going to talk about liquid medication. So this could be liquid medication by mouth, or liquid medication by IV, or liquid medication by intramuscular injection or subcutaneous injection. So it's a liquid. And the liquid we like to deal with is milliliters when we're drawing up medicines. So when you look at this question, the doctor has prescribed 15 milligrams of a drug. Available, and I'm so sorry that when I transferred my files because I got a new iPad, it got a little squirrely. Don't listen to me complain. Available is what? 3,000 micrograms per milliliter. So what the heck does that even mean? That means that the pharmacy sent me this vial right here. They sent me this vial, and it says a drug. That's the name of the drug. A drug, or druggie, as I wrote. That means that every 1 milliliter of this druggie in the vial has 3,000 micrograms in it. And perhaps this whole vial has a total of 3 milliliters in it. So what am I supposed to do with this information? How am I supposed to figure out? Because what do I need to know? I need to know how many milliliters I'm going to give to my patient, whether it's by mouth, whether it's by the vein, whether it's by injection. I need to know how many milliliters to pull out of this vial. So how do we figure it out? The same way we've been doing everything. I start with my given. 15 milligrams. That's what the doctor wants. I have to figure out 15 milligrams out of this vial. And what is my wanted? This question tells you how many milliliters will you give the patient? So I need milliliters on top. So it's a process of elimination. So available is micrograms. So now I have to know a conversion, milligrams to micrograms. So 1 milligram is 1,000 micrograms. So my wanted is milliliters. I have to go milligrams to micrograms. All right. So I've already used my given. I know what my wanted. I know my path. I know my conversion. So how am I going to get rid of the milligrams? I'm going to use my conversion. 1 milligram is 1,000 micrograms. Now, how do I get rid of micrograms?
$3,000 at the bottom.
That's
as a
right.
numerator.
3,000 micrograms per 1 ml. Beautiful. And when I write that, I've gotten rid of all my unwanted units, and I'm left with just the milliliters. So now, I just have to do the math to figure it out. So 15 times 1,000 is, I'm going to write it down here, is 15,000. And 1 times 1 times 3,000 is 3,000. So now I'm going to divide 3 into 15,000. And what will my final answer be?
5 ml.
5.
5. 5 milliliters. So I'm going to withdraw 5 milliliters. So actually, this should say 5, not 3 milliliters in the vial. So I'm going to, when I withdraw 5 milliliters with a syringe from this vial, that means, and I give it to my patient, that means they will receive 15 milligrams of the drug. You would not be able to figure that out without dimensional analysis, without using conversions. So your final answer is you're going to give 5 milliliters, and that's going to give what the doctor ordered, 15 milligrams. So now instead of tablets, we're just using liquids. So for the next one, given is what the doctor orders. So what's the given?
2,000
2,000
micrograms.
All right, 2,000 micrograms. What's my wanted?
mLs.
mLs, because it tells you. And what's available?
0.4 milligrams slash
0.4
milliliters.
milligrams.
So do I need to do a conversion?
Yes.
2 factor.
1 milligram is?
1,000 micrograms.
All right. I'm going to pause and I want you to solve this question. So I start with my given. My wanted is milliliters. So I have to do a conversion because what's available is in milligrams. So when I do that, I have to get rid of the milligrams or the micrograms. So I use my conversion. So 1 milligram is 1,000 micrograms. And to get rid of the milligrams, I use what's available, what the pharmacy sent me. And the label reads 0.4 milligrams per milliliter. That gets rid of my milligrams, and I have milliliter in my numerator position. Excellent. So now it's just math. So when I multiply across the top, it is 2,000, and across the bottom it's 400. And when I divide, it will give me a solid 5 milliliters. Now, somebody asked a question in the chat, which I missed because I don't know why some people are not coming up in my main chat. And please, yes, send your messages to me directly, not to everybody in the chat. So just go to me, send the answers to me directly because it's people are seeing it before they're finished. Thank you. So please, can somebody tell me what I want to say? Oh, I was saying about somebody asked a question about zeros. Do we always have to put a 0 before the decimal if it's less than 1? And the answer is absolutely. Absolutely. For example, if I was working in pediatrics and the doctor said give 0.5 of this heart medication that will help slow down the heart rate, 0.5, and I read it as 5. So let's say he said give 0.5 milligrams or 0.5 milliliters, but I gave 5 milligrams or 5 milliliters. I could potentially kill the patient. So we put a 0 before the decimal so we don't misread it as 5. And the same is true if the doctor said give 5 to the baby and I wrote 5.0. What could I mistake 5.0 as?
50.
50. So the lesson is, and the rule is, if you look at the directions, is you can never have a trailing 0, which is this. This is a trailing 0. And you must always have a 0 before the decimal. It's just so we don't misread the orders. So never have a trailing 0 and always have a decimal before, a 0 before the decimal, I'm sorry. So great question. Thank you for asking that. All right. Now, these were just examples of what you have available to you. Pharmacy sends you a med. It's got on the label, it tells you what the strength is and how many milliliters. But now there's something called reconstitution that you should have looked at when you were practicing and preparing. So reconstitution is basically you're making the concentration of the drug. You're making the label that you can use. So what the heck do I mean by that? Well, there are some medications that come in powder form. For those of you who have children, when they have an infection and they prescribe amoxicillin, let's say, the amoxicillin, when it's the pharmacy has it, when they get your doctor's order, they mix it with water because in the actual container it's powder. So they mix it and it's called a suspension. And it usually smells like delicious bubblegum flavor. I wish adult medicine tasted like that. But they mix it. But this is also true for intravenous. Some intravenous medications come in a powder form. So the nurse has to mix it. And when we do that, it's called reconstitution. That's all that means. It's just mixing the powder medication with a diluent. So a diluent is just what we dilute the medicine with. And that could be either sterile normal saline or sterile water. So basically, we're going to withdraw whatever amount is prescribed or recommended by the pharmacy out of the diluent, the vial of liquid, and put it into the vial of powder to mix it into a liquid. Because we can't give powder into the vein. Do you all agree? If I put an IV in your arm, which goes into your vein, I can't pour powder in it to give you medicine. I have to dilute it, and that's reconstitution. So this is called reconstitution because we make it on the floors. We dilute this on the floors. We reconstitute it on the floors. So you just need to understand the process of how to do that. So here's a real example of penicillin. I'm going to blow it up. Penicillin comes in a powdered form, and nurses will have to dilute it with sterile water to dissolve the powder into a liquid, milliliters. And I want you to notice how many units this one vial has. 5 million units in the vial. So remember what I said, get a calculator that holds a lot of numbers. This is exactly why, because you're going to be dealing with large numbers, and I want your calculator to give you a chance. So let's talk about the first question. Add 8 milliliters of sterile water, 8 milliliters of sterile water to a vial. Now this vial says 5 million, but the example is 2.1 million units of medicated powder. So if I add 8 milliliters to 2.1 million units, what's my concentration that I just created? And it's not a trick question. What's my concentration I just created?
Your concentration is 2.1 million units of the medication in 8 milliliters
That's
of
it.
liquid.
That's exactly right. You just need to know how to write out millions. And people don't know how to write out millions because I don't know about you. I don't have millions that I have to solve or take out of my bank account. So 2.1 million is written as 2,100,100 units. And I added 8 milliliters. So that's my concentration. That's what's now available to me. What I just made, a concentration. Okay, so I withdraw 8 milliliters, I put it in this vial, I mix the vial, and my concentration is 2.1 million in 8 milliliters. So what did the doctor order in this question?
1 million units.
He wants you to give 1 million units. So I need to know how to write 1 million units. And I write units underneath it because when I was in school, I mistook the U for a 0 and I got an answer wrong. So I will never write units next to my zeros because I don't want to mistake it for a 0. So now I have 1 million units as my given. And what is my wanted?
Mls.
Milliliters. It says how many milliliters are you going to give? So now I have to get a process of elimination like we've been doing, right? So I'm going to use what I made. 2.1 million units in 8 milliliters. That crosses off my units and it leaves me with milliliters. So now for those of you who are comfortable with fractions, you can remove some zeros. Just remember, if you remove from the top, you have to remove the same amount from the bottom. So what do I mean by that? I can take away 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can remove the same amount of zeros from the numerator and the denominator to make it a smaller number. Okay? Because some of you will use a calculator when you put in 1 million times 8, your calculator will say E for error because it can't hold the digits. So get comfortable with crossing off zeros if you have to. So now my new math is 10 times 8 is 80, and 21 times 1 is 21. So what's my answer? 80 divided by 21, what does your calculator give you?
3.80.
3.80952.
4 milliliters.
What's my rounding rules? Any number
Four.
between 1 and 10?
4 milliliters.
Oh, what is the rounding rules? Any number between 1 and 10?
Pero
I
be
to the
nearest 10.
0.8.
I round to the tenths. I
Oh,
round 1 decimal. So I have to look to the right, and the right is a
so
0.
3.8 milliliters.
So the answer is 3.8 milliliters. 3.8 milliliters. Now let's say you put 4 milliliters on the exam, but I see your work, I will only take away 1 point. If you write 4.0 milliliters, I still take away 1 point, but then I come to your house. No. All right. So remember, no trailing zeros. So this one is 3.8 milliliters. All right. I'm going to give you a minute to solve. What? My wanted is 625,000 units. My wanted is milliliters. I'm sorry. My given is 625,000 units. I don't know why this keeps switching back. And I'm going to put that over 1. So I have to get rid of units. And I'm going to use what I just made. And what did I make? 1.3 million units in 5 milliliters. And that's the big secret with reconstitution. It's just about getting comfortable using the zeros, getting rid of zeros, and then knowing how to write out millions. So you can cross off 3 zeros. Just make sure you cross off the same amount. And 625 times 5 will give me 3125. And then 1300 times 1 is 1300. And when I divide, it will give me 2.4038 on my calculator. Any number that falls between the number 1 and the number 10, we round to the 10th position. So I look to the right. This is the right. It's not 5 and up, so I don't change this 4 to a 5. So my answer is 2.4 milliliters. Okay? Got it? All right. Got it. All right, cool.
Wait,
So
can
I
you
do.
scroll right back up real quick, Professor? Just one.
Yep.
Oh, okay.
Oh, what you
So-
do? Did you find it? Share it with the group.
Yeah,
one.
no. I
Christina's crying.
am. I lost 5 points again.
She's like 5 points. She's coming to my house.
Oh no.
Who is this woman? Okay.
I figured it out. Okay.
All right. Cool. All right. Now, those were all considered 1-factor questions. So what is a 2-factor? 2-factor means we add the weight, the patient's weight. So when you look at this question, tell me what the given is.
.2 milligrams/kilograms
Yeah,
of
0.2
IV
milligrams per kilogram.
every 6 hours.
So he's going to get something intravenously every 6 hours, and it's got to be 2.2 milligrams for every 1 kilogram of his body weight. So my wanted is what? What am I giving?
Milligrams?
I know I'm giving milligrams,
Oh,
but
no.
how am I giving it? What am I
Milliliters.
actually
Milliliters,
giving?
milliliters.
Yes. So always remember, what am I going to actually give the patient. So this question actually says it, how many milliliters? So what's available? $600 micrograms available is 600 micrograms. So they sent me a vial, and the vial says there's 600 micrograms per milliliter. That's all that means. So do I need any conversions?
Yes.
Yes.
Yeah. So I need milligrams to micrograms, and that's 1 milligram is 1,000 micrograms. So you see how it's the same thing over and over again. But now it's a two-factor. How do I do this? How do I write this? Well, what we're going to do is the way we set up the question is still with the given, but now the given has a numerator and a denominator. So 0.2 milligrams over kilogram. Because now there's two parts to my order, right? So now I need to add the patient's weight. So what does the question say the patient's weight is?
6 kilograms.
kilograms.
All right, 6 kilograms. So my wanted is milliliters. Only the numerator. So I should have nothing in my denominator. But what do I have sitting here? A crusty little kilogram. How do I get rid of that kilogram?
6 kilograms over 1.
Yeah. To get rid of this kilogram, I need kilogram written here. And the only thing in my question with kilograms in it is the patient's weight. So I'm going to use 6 kilograms over 1. So now I've used the patient's weight, I've used the doctor's order, and I know where I'm going. So you see, when I cross off all this stuff, I know what's left that I can use. So when I use that patient's weight, I can cross off the kilogram. Now there's nothing in my denominator. So now how do I get rid of milligrams and get to milliliter?
1,000 micrograms over 1 milligram.
That's right. I have to put milligram down here to get rid of it here. Now, how do I get rid of micrograms and get to milliliter?
1 ml over 600 micrograms.
That's it. You can only use what's in front of you and then add a conversion to make it work. So it's really a process of elimination. So now these questions start to get longer and longer and dumber and dumber and harder. But if you go through these steps, you will be able to figure it out. So now it's just math. It's crazy math, but we got to do the math. So now it's 0.2 times 6 times 1,000. So what does that give me across the top? So I'm going to write it below it. So 0.2 times 6 times 1,000 is 1,200. And 1 times 1 times 1 times 600 is 600. And now when I divide 600 into 1,200, what's my final answer? How many milliliters am I going to give the patient?
2.
2.
2 milliliters. And I'm writing it like that. No 0.0 after, or I show up at your house. So the answer is 2 milliliters. So let's do it again. But I'm going to let you do it. And you can use these steps or not, but I'm going to give you a couple minutes to solve. Literally just 2 minutes, okay? Because we're running behind schedule. All right. So yes, you guys are doing really good. I don't know why it's not coming to me directly, but okay, we'll figure it out. Good job, CC. Got it. Stacy. Okay, got it, Stacy. And Christina. Oh no. Okay. All right, let's do it. I'm going to do it. All right, a medication is ordered to be administered 1 milligram per kilogram, IV every 6 hours. It's available in 2,000 micrograms per milliliter. The patient weighs 15 kilograms. How many milliliters will you administer? So the doctor ordered 1 milligram per kilogram. And I know I need to solve for milliliters. So I got to get rid of the crusty kilogram. So I'm going to use the patient's weight. And I'm going to put it over 1. So when I use that, I cross off what I've used. and I cross off the unit of measure. So now I have to get rid of milligram. So the only thing left in my problem is in micrograms. So it should trigger that I need a conversion. And the conversion for milligrams to micrograms is 1 milligram is 1,000 micrograms. Cool. So I got rid of the milligrams, but now I got to get rid of micrograms. So I'm looking at my problem. The only thing left is the concentration that the pharmacy delivered. So I get rid of the micrograms by putting 2,000 micrograms in the denominator and 1 milliliter in the numerator. And when I do that, I'm left with with milliliters only in the numerator, no other unit of measure. So now it's just math. So when I do the math across the top, it will give me 15,000, and across the bottom is 2,000. And when I divide, it'll give me a solid 7.5 milliliters. And because it's between number 1 and 10, I round to the tenths. I'm going to leave it 7.5. So what happens if you make it 8? I take away 1 point. Okay? But the right answer is 7.5 milliliters. The other version of this question is, what if the patient's weight is provided in pounds? So what would we do? You still follow the same steps. I start with the given, but look at how the given is written. 6 milligrams per kilogram instead of written as 6 milligrams / kilogram. Guess what? It means the same thing. It doesn't matter. So I start with 6 milligrams per kilogram. So I know my given and my wanted is milliliters. Okay, I know where I'm going. So it doesn't matter to me where you want to start, okay? So if you want to get rid of, I like to get rid of everything on the bottom first, the denominators first. So I have to get rid of the kilograms. So I look to the patient's weight, but it's in pounds. So what do I do to get rid of the kilogram?
Convert the 58 to kilograms.
So I can do that separately, or I can just get rid of it by saying what? 1 kilogram is 2.2 pounds, right? And cross off the kilograms. But now I got to get rid of pounds. I can use the patient's weight now, right? And when I do that, it still crosses it off. Now, some people want to convert the weight separately. I just put it in the problem, and that's what I recommend doing. So now I've gotten rid of kilograms and pounds. So how do I get rid of milligrams? Because all I need is milliliters. What have I not used in this whole problem when you're looking at it?
What's available?
What's available? So I just have to make sure I put it in the right position. 400 milligrams in 10 milliliters. And that leaves me just milliliters in the numerator, no other units of measure. So that's how I know I'm correct. So now it's just math. So when I do 6 times 58 times 10, it should give me 3480. And when I do 2.2 times 400, it will give me 880. When I divide, my calculator will give me 3.954. What's my final answer?
4
ml.
Yes, 4 mLs. Very good. The rule is 1 to 10, you round to the tenths, Professor K. You're right. So when I round to the tenths, I look to the right. It's 5 and up. So I have to make this 9 a 10. And when I do that, it makes it 4. So the final answer is 4 milliliters. Now, if you were here and you were like, oh my God, I cannot remember, my brain just slid out of my left ear. Just leave that. Just leave 3.9. I'd rather you lose 1 point than all 5 by making a silly error, okay? All right, so what other kinds of two-factor problems do we have? My favorite kind, the IVs. So there's a couple things I want to talk about when it comes to IVs, and hopefully you will remember it when you're taking your test. So do you all know what I mean by an IV? Intravenous?
Intravenous.
Okay. It means fluid is going into someone's vein, right? So either the IV can be given in a couple ways. So I want to show you something actually. So these are example of IV fluids, right? So we have IV fluid bags that come in 1,000 milliliters. We have IV bags that come in 500 milliliters, 250 milliliters, 50 milliliters, 150 milliliters. And that's just how much volume of fluid is in a bag. All right. So we need to know, the doctor will order how much volume they want you to give, but you have to know how to solve to how to give that fluid at a certain rate. This is called an IV pump. It's a computer. If you have an IV pump, you can only deliver the fluids at milliliters per hour. If you work in a facility like a nursing home that doesn't have IV pumps, they deliver fluids drops per minute.
Gravity.
Through gravity, right. So one is a pump and one is gravity. So I'm going to be talking about the two different ways you can give fluids. And then the words I'm going to tell you hopefully will resonate and remind you when you're taking the exam and in your practice. Because when you go and start practicing, you have to take Calc exams, your jobs. All right. So now, this time we're going to solve for a certain type of way. The doctor orders 1,000 milliliters of half normal saline. That's the type of fluid, to infuse over 8 hours via a pump. The question asks, what is the infusion rate? So here's what I want you to remember. No matter what is in that question, if it asks you to solve for rate, and get in the habit of writing it down, you have to figure out a couple things. The rate just means how fast you're going to run it in. First thing, are you using a pump? Yes or no? In this question, are we using a pump?
Yes.
Yes.
So what am I solving for? What's my wanted?
Milliliters per hour.
Milliliters an hour. All right. I need milliliters over an hour. Numerator, denominator. Now I'm solving for two-factor. So if I need to solve milliliters an hour, what is the doctor saying? What is the order saying?
Give 1,000 mLs over
Over
8
8
hours.
hours.
Volume over time.
Volume over time. Every time. So do I need to do anything else?
No.
No, because I have milliliters in the numerator and hour in the denominator. So what am I going to put into the IV pump? What's the answer?
125 milliliters per hour.
That's it. That's the answer. The answer is I'm going to go and put 125 milliliters an hour. So in the pump, I'm going to press 1, 2, 5 and start. And that patient will receive 125 milliliters an hour. And that means in 8 hours, they would have gotten 1,000 milliliters. So what's the answer to this one? What is the infusion rate? If it says rate, is there a pump or not?
Yes, there's a
So what am I solving for?
volume over
ml per
time.
hour.
So milliliters an hour,
Milliliters
right?
over an hour.
So if I'm solving for milliliters an hour, I'm looking for that volume over time. So the doctor said give 1 liter per day. Oh, professor. How many milliliters is a liter?
100.
1,000.
1,000.
Oh, 1,000. You know, you guys have 100 on here. Oh, never mind. I'm looking at something.
I can do the conversion in my head. 1,000 milliliters per day. Am I going to write per day?
24.
There's
24 hours.
hours in a day. Do I have to do anything else?
Math.
Just
Math.
math.
42 milliliters per hour.
So yes, when you do the math on this one, your calculator will say 41.6666. Any number greater than 10, I round to the whole number. We're using a computer. It can take a
42.
decimal, but I'm going to follow the rounding rules. Any number greater than 10, I round to the whole number. I look to the right. It's 5 and up, so I round this number up. The answer is 42 milliliters an
per
hour.
hour.
That's it. So this question, it's asking you rate. There's the word rate. It can say infusion rate, drip rate, flow rate, gravity rate. If it says the word rate, you have to decide, does this question have a pump?
Yes.
So what am I solving for?
Milliliters
Per
over.
All
hour.
right, you feeling it? You're feeling me, right? You're there. You're there.
Yes.
All right, so
Yes.
now I'm looking for that volume over time. The doctor said 500 milligrams over 2.5 hours. milliliters over 2.5 hours. What is DF8?
Drop factor.
Do I need it?
No.
I don't need it because I got a pump. Drop factor is only for gravity. So everybody's like, why do you put it in the question? Because in practice,
Gotcha.
it's not to trick you. Because in real clinical practice, you're going to use tubing that automatically includes the drop factor on it. Why do I need to know that, Professor? Well, what if your magical computer stopped working during the infusion? Guess what you can do? You can figure out through gravity how to run it using the drop factor. So that's why I say, if you know you're looking for the rate, if it's using a pump, you already know what you're solving for. And I'm going to show you the example. It'll make sense. So now I have milliliter and I have hour. So now it's just math. So what is my infusion rate on this question?
200 milliliters per hour.
So I'm going to punch into the computer 200 and hit enter, and it's going to deliver 200 milliliters per hour. And that's how you solve for these questions. Now, what is the drip rate? Rate. Do I have an IV pump in this question?
No.
No.
Oh, so I know pump. Do I have a drop factor?
Yes.
Yes.
What am I solving for?
Just per minute.
Drops per minute.
Drops per minute. I don't have a pump and I have a drop factor. So my wanted is drops per minute. So where do I start? The doctor said give what? Volume over time. 1 liter per day. 1 liter is how many milliliters?
1,000.
1,000 all day. And how many hours are in a day?
60 minutes.
No, how many hours are in a day per day?
24.
24 hours.
All right.
And 1
So
hour
now
has
I'm
60
looking, wait a minute.
minutes.
I got to get to
And-
drops and minute. And I have milliliters in hours. How do I change hours to minute?
1 hour on the top, 60 minutes.
There it is. Boom. There's my minute. I have to get rid of milliliters and get to drops. What have I not used in my problem?
10 drops / 1 ml.
Yeah, so a drop factor just means how many drops it takes to make 1 milliliter. So in this IV tubing, 10 drops equals 1 milliliter. So, so I'm going to use that. So, 10 drops in 1 milliliter. Cross off my milliliters, and what's left? Drops. So now I have drops and minutes, drops and minutes. So now it's just math. So what's the answer for this one?
7 drops per
7
minute.
drops per minute.
Good. So your final answer will be on your calculator, 6.94.
6.9.
But I can't split a drop because I'm not a magician. Because the drop is literally falling inside the chamber. There's no way to split it, and there's no computer. So this answer is 7 drops per minute. Okay. I'm going to give you a minute to solve this one. This one is testing your knowledge of the of what some of the abbreviations mean. So calculate the infusion rate. There's the word rate. Do I have a pump? In this question, does it say the word pump? No pump.
No.
Do I have a drop factor?
Yes.
Yes.
I do.
Yes.
So drop factor is the micro drip. And you have to remember the micro drip is 60 drops
60
per milliliter.
per minute.
Okay. So we're going to still do the same process. So I have no pump and I have a drop factor. My wanted is drops per minute. Beautiful. All right. So the doctor says give 1,500 milliliters of IV fluids over 8 hours. And I have a micro drip tubing, so no pump. So hours to minute is 1 hour is 60 minutes. Beautiful. There's my minutes. Now, how do I get rid of milliliters and get to drops? You already know it's 60 drops per milliliter. And that leaves me drops in the numerator position. Awesome. So now it's just the math. So the math across the top is 1,500. No. Oh, you know what I did? I did this on my sheet. So do you guys know that if you have the exact same number in the numerator and the denominator, you can cross it off? You don't have to. You can do the long math. But I did the short math to show you that you could cross off identical numbers from the top and the bottom. So because I crossed it off, I have a smaller number to work with. My final answer on my calculator is 187.5. And because it's drops and it's greater than 10, we look to the right, and I'm going to make the 7 and 8. So the answer is 188 drops per minute. And a lot of you got it, so that's really good. Very good work. All right. I want you to try this question. Follow the same pattern that I've been using. I'm just curious to see if you'll be able to get that. All right, so I have some answers coming through. So I anticipated the struggle, and it's all right. There's a reason I'm showing you this. Number one, you need to know how to do this. But number two, when I say it, it usually helps people understand it. So a patient is to receive 500 milligrams of a medication IV piggyback, and it's just a smaller bag, a 50 milliliter bag. And you're going to give that 50 milliliters over 45 minutes. How many milliliters an hour will the nurse set on the IV pump? So this is telling you what you're solving for. How many milliliters an hour because you're using a pump. So it's asking you about the flow rate, the infusion rate. It's just not saying it. But if you're solving for milliliters an hour, drops per minute, you have to know its rate. So with that being said, you don't need the strength of the medicine. I didn't ask you about the strength. I see you shaking your head, Stacy. I'm just asking you to how fast you're going to run that 50 milliliters over 45 minutes. How many milliliters an hour that's going to be. So this is classic for any nursing student. Number one, you're all chronically overthinkers. Number two, you lovingly think I'm trying to trick you. I ain't got time for that. And you will absolutely read into every question because you're so desperate to be right because you don't want to harm anybody. And I totally get it. So knowing that new information, remember when you guys were all just saying volume over time, volume over time. It's telling you to solve for volume over time. But what did you do? You tried to squeeze in a strength. Because why else would it be there? Because that's how doctors write orders. So volume 50 milliliters over time, 45 minutes. So I got my
And you
volume.
have to convert the minutes to hours. That's where I screwed up at.
That's it.
You got to convert the minutes to hours.
That's it.
Put the
60
60
minutes
minutes in.
is 1 hour. And that is it. So now your answer on your calculator will be 3,000 over 45. Your calculator will say 66.66, Matthew. I don't know if you just had a typo, but 66.66, I would round that to 67 milliliters an hour. All right. So it's the same thing when you're doing drops per minute. This question tells you about, it has 50 milligrams in this 50 milliliter bag. It tells you to run it over 30 minutes and it gives you a drop factor. And it tells you what you're solving for, drops per minute. So you know it's a rate. So I don't care. I mean, I care about the strength, but not right now. I just need to know how fast it's going to flow into that patient. 50 milliliters over 30 minutes. So I have minutes, but now I just need to change milliliters to drop. How do I do that? There's 10 drops per milliliter. And that is it. So this one would be 500 over 30. My calculator would give me 16.66, which I would round to 17 drops a minute. All right. So while we're going through this, if you know, man, I gotta practice that before my exam, just go to that part and just practice it. Here's another type of question you should be prepared to answer. And this has a lot of information in it. But it's all about going back to that basics. So right off the bat, if I read it, the pump is set to deliver 13 milliliters an hour. So you're going to give a med that has to go through this pump. And when they deliver the medicine in this big bag, there's 1 gram in 250 milliliter bag. So it's a 250 milliliter bag of fluid with 1 gram of medicine in it. And you have to run it at 13 milliliters an hour. It's offering me a drop factor of 20. And it's telling me what my wanted is. How many milligrams an hour is the patient getting? Milligrams per hour. So I know where I'm going, milligrams per hour. And what's that magic word that's in here? I know I'm using a pump because it says it, and plus it's telling me it's running at 13 milliliters an hour. So I need to know that because what do I do with the drop factor? I get rid of it. I don't need it.
Yeah.
So now look what I have left in my question. 13 milliliters an hour and the concentration of the med. So what do you think my given is? What do you think I should start with?
$13 milliliters over an hour.
Yeah. Volume over time. And not only that, if I need hour in my denominator and I have something with hour in my question, I'm starting there. So I've used 13 milliliters an hour. I've used everything in my question except for one part, the concentration. So I need to figure out how to get rid of milliliters and get to milligrams. So what in my question can I use to get rid of the milliliters?
1 gram over
250
250
milliliters.
1
At the
gram
bottom.
is 250 milliliters. Cross that off, cross off my concentration. But I need to get rid of grams to get to milligrams. So how can I do that?
1,000 milligrams over a gram.
Yeah. 1 gram is 1,000 milligrams. And now I have what I need in my problem. Milligrams over hour. So now it's just math. So when I multiply 13 times 1,000, it will give me 13,000. And 250 times 1 is 250. When I divide, I'll get a solid 52 milligrams an hour. So people always ask, why the heck do I need to know any of that? Because honestly, if something happens with your patient while they're receiving 13 milliliters an hour, it's not uncommon that the doctor will say, well, how many milligrams an hour are they getting? Like, when did this happen? How much? So it's information that you have to be able to flip flop around. Now, I know nowadays with technology, it tells you, but technology breaks down. So you have to be familiar with it. And the NCLEX doesn't care about technology. The NCLEX cares that you know how to solve these problems just in case the technology fails, which it can. All right. Now I know we're going to definitely probably run over, but that's okay. I'm going to keep going. Now, 3-factor. You've done 1-factor, 2-factor. Now we're going to do 3-factor. And 3-factor means there's 3 parts to the doctor's order: the strength, the weight, and the time. Now, somebody asked in the questions, when would we need to use abbreviations and when would we need to use military time? Well, when we're timing anything with meds, it's always answered in military time if I'm asking for a time. So that's where you would use military time. As far as abbreviations, you need to know, and I'll show you why, what every 4 hours is, what TID is, what QID is. Because if there's a question where you have to solve what are you going to give per dose, and they get 4 doses, but it's written as QID, you need to know that. So that's where you will use your abbreviations. Okay, so let's do it. How do I start a 3-factor?
1 milligram slash
8
kilograms a day.
milligrams per kilogram per day.
day.
That's how you're going to write it. Just like it's written here, you're going to write it just like that in the numerator and denominator. Because remember, the 2-factor was 8 milligrams over
What's the
kilograms.
baby dose before?
So this one we added time. Okay, so now I've used that. But what is the question asking me?
Daily
What
dose.
is the dose for a 105-pound patient goal? What is the dose for an adult weighing 105 pounds? What is the daily dose for a patient that weighs 105 pounds? So when they say dose, what do they mean dose? What's the only thing that has anything to do with this, with dose in this question?
Milligrams.
How many milligrams a day?
Milligrams.
Yes. So dose is how many milligrams a day. So if you write that in your wanted, you will know what to get rid of in your question. So what do I need to get rid of?
Kilograms a
The
weight.
crusty
Kilograms.
kilogram. It's still there. I gotta get rid of that crusty kilogram, because I want milligram and I want day, but that crusty kilogram is sitting there. So how do I do it? I use the patient's weight, but it's in pounds. So 1 kilogram is 2.2 pounds, and the patient weighs 105 pounds. I put that over 1, and I cross off everything, and now it's just math. So 8 milligrams times 105 is 840, and 2.2 times 1 is 2.2. And when I divide that, my calculator will give me 381.81. What's my final answer?
382.
382
Milligrams a day.
milligrams a day. Now, somebody asked, do I need to write the day part? No, I will give you the points, but I do want you to try to remember to write that, because when you move through the program and you take other calc exams, they may not be as forgiving as I am. But because we ask you how much per day, if you wrote 382 milligrams, it is technically correct. So with your newfound knowledge, solve this question. Oh, shoot. All right. So the doctor said 4.6 milligrams per kilogram per day. And they're going to get it every 6 hours. The patient weighs 7 kilograms. The med is available in this ridiculous dose. But they need to know, what are you going to give at the 7 a.m. dose? Okay, so we know we're going to give, it comes as a liquid. So how many milliliters am I going to give for a very specific dose? Okay, cool. So a process of elimination. I get rid of kilograms by using the weight. 7 kilograms, so it's a child. Get rid of day by writing the word day, and every day the patient will get 4 doses. So someone had an answer that was wrong because you probably forgot the 4 doses. So now I have doses and I got rid of day. So now how do I get rid of milligrams and get to milliliters? Well, I've used this. The only thing I haven't used is the concentration, and it's in grams. So I need a conversion. So 1 gram is 1,000 milligrams. And that gets rid of my milligrams. And now to get rid of grams, I use the concentration. 0.008 grams in 4 milliliters. And that gets rid of my grams. And now I have milliliters over dose. And somebody asked a great question. How do you know when to go from the dose and then go to the milliliters? Well, it's what's available to you. That's how you know what to solve for. The other question that we first did only had milligrams as an option. There was no other option in the question. But this one gave you something that had what you were actually going to administer to the patient. So now we have all this information written down properly, and now it's just math. So when we do the math across the top, it'll be 128.8 and then 32 on the bottom. When we divide on our calculator, it'll be 4.025. So any number between 1 and 10, we round to the 10th spots. I look to the right. I don't change this 0 to a 1, so it stays the same. But what's the rule? I can't write 4.0 because then the professor will come to my house. So the answer is 4 milliliters with no trailing 0. Okay?
I have a question.
Sure.
So on the 3rd step of your math, it says day over 4 doses. How come you're separating it like that? Because what did I do? I'm trying to see. I think I just kept it as 4.6 over, and this is completely wrong, obviously, 4.6 over 24 hours in a day. I didn't do it as kilograms/day because I thought those were completely separate.
Did you get the right answer?
No, I
I
didn't.
was going to be like, wait, did that work? Well, that's awesome if it did. Yeah, no. You can't, even if you transferred it to 24 hours, then you would never get the result of the problem because we have to change the day to dose. That's why changing it to hours won't work. Because you're
Okay.
thinking about IV fluids.
Yeah.
Yeah, no, that totally different.
Okay, so how did you get to 4 doses?
Well, every 6 hours, if you give a med every 6 hours, how many doses is that in 24 hours?
Got it. Okay.
Yeah, that's what it is. So it's
Okay.
all about the medication doses.
Got it. Thank you, Professor.
Sure. Let's see. I'm trying to keep up with everybody.
I have just one question about
Sure.
the last question that we did. I got 4, but I messed up my conversion and I did 1 gram over 100, but I still got 4. Is that
Really?
yeah?
I don't know how that
it's
happened.
still counts to 4,
Maybe in your calculator you used 1,000.
maybe.
Yeah, because at my math it comes out. Yeah, it would be 32. Well, let's try it now. So 4 times 100 is 400 times 0.008 is
Oh, it's coming up as 3.2. So maybe when I did the math, it was.
yeah.
It
Let me
was.
just make sure my math is all right.
I got the same thing. You got me scared. I'm like, this the hardest one we got.
4 times 1,000 times 0.008 is 32.
Yes. Okay.
4 times 100 times 0.008 is 3.2. See how
Okay.
easy it is to make an error?
Yeah, definitely.
Woo!
But somehow I got to the correct answer, so I won't.
Take the win. Because even if you did your setup wrong, and you got the right answer, I would see that, but I would probably guess that you probably put in the calculator the right number, not even knowing it.
Thank you.
Sure. All right, so now we're moving on to three-factor IV. Okay. So three factors still have three elements to the order. You still write it the same way. Okay. So I've used that. What am I solving for in this question? What's my wanted? Go ahead and read the question.
You're solving for infusion rate for the pump.
Okay, so what's my wanted?
Milliliters per hour.
That's right. Milliliters per hour. Cool. So I know where I'm going. So do I need the drop factor?
No.
No. Get it out of there. All right. So I have to end with just milliliter an hour. So there's my crusty kilogram.
I might write that on the exam.
Go do it, because I bet you won't forget now, right? 1 kilogram is 2.2 pounds, and the patient weighs 120 pounds. I do it all for the shock, just so you won't forget. All right, so I got rid of crusty kilogram. So now, how do I change minute to hour?
60 over 1.
60 minutes over 1 hour. Yeah. All right, cool. My denominator is done. Now I have to get rid of micrograms and figure out how to get to milliliters. What's the only thing I haven't used in my problem?
Micrograms?
I haven't used the concentration, so I have to change it to micrograms, to milligrams, right? Because the only thing left is this in my problem, 500 milligrams in 500 milliliters. So I have to do a conversion. 1 milligram is 1,000 micrograms. Cross off my micrograms. So now how do I get rid of the milligrams?
Five hundred
That's
ml
what?
over 500
Yeah,
milligrams.
that's it. 500 milliliters over 500 milligrams. That crosses off my milligrams and leaves me with milliliters. So that's a big problem, right? That's huge. So you can cross off like amounts. So I would cross off the 500, or you can use it. It's totally up to you. And now it's just math. Disgusting math, but it's math. So when you multiply across the top, it'll give you 158,400 over 2,200. And when you divide, it'll give you 72 milliliters an hour. So when I hang this medicine in this bag and I go up to the pump and I type in 72 and hit 0, it's going to run this medicine at 72 milliliters an hour. And that's what the question asked me. And when it does that, it is actually giving the prescribed dose, 22 micrograms per kilogram a minute. Without dimensional analysis, you would never have been able to figure that out.
Question, Professor.
Sure. Yes.
So a doctor would give this the 22 milligram.
Oh, yeah.
Okay.
Yeah, if you're working in, it's usually you guys have just entered the realm of critical care. You are actually calculating medications that are given in the critical care setting.
Because I've seen this in the chart and had no clue. So I just,
Yeah.
I skipped over that.
It's like next.
Yeah, I only worked on the discharge planning part. I didn't care about that.
You're like, what? No. Yeah, so patients in the critical care, when they're getting cardiac meds or sedation, this is how the meds are given. They're administered in this way. And I mean, now in the hospital setting, they have pumps that are they're smarter pumps now. So you can literally type this in and with the concentration. But like I said, I work in 2 facilities and the pump programs can fail or they're not loaded properly, or you have a different concentration that was available because maybe the manufacturer didn't have what you normally order. So these are real calculated rates that you will do. And when you go for your first job, if you work at any of the hospitals that I work at, you are given an exam. So, and trust me, by the time you graduate, you will know this stuff. But I think you guys are doing pretty good so far. I like it. So with that new knowledge you have right there, now I want you to solve this question. All right, you guys are doing good. Very good. Let me see. Good. All right, you got it, Cashley. All right. All right, let's do it. So let's start with our three factor, 100 micrograms per kilogram per minute. And it says infusion rate, and I have a pump. So it's milliliters an hour all day long. So like I said, it doesn't matter where you start. So let's start with the numerator. To get rid of micrograms, I look to see that it's ordered in milligrams, so I need a conversion. So 1 milligram is 1,000 micrograms. And now to get rid of milligrams, there's 300 milligrams in 150 milliliters. All right, cool. So I got my numerator done. So now let's go to the crusty kilogram. So the crusty kilogram, to get rid of it, I need a conversion because the weight is in pounds. So 1 kilogram is 2.2 pounds, and the patient weighs 225 pounds. I put that over 1. And I get rid of all the kilograms and all that other stuff. So now I got to get minutes to hours. So there's 60 minutes in 1 hour. So you can see how the process is just about getting rid of the unwanted. And if you know where you're going, you can figure it out. So when we do all this, you can cross off zeros to help it make it easier. 1, 2, 1, 2. Let's see, we got another 2 we can do. 1, 2, 1, 2. You just have to make sure when you cross off your zeros, it's the same on the top as it is on the bottom. And when you do that, you can multiply 2250 over 66. And then that will give me 306.8, which I would round to 307 milliliters an hour. That's a nice problem. I love it. All right, stays all good. You got it. Okay, cool. Let's see. Good. You got it, Goldie and Diana. Don't forget your milliliters an hour, Diana. All right. And Alex, yes. Nope, sorry, Alexis. Yes. So sorry. All right. I know, I'm fading fast. All right, here's the military time. Okay. So the military time is where
Sorry,
you're
Professor,
going
can
to...
you just scroll back real quick?
Sure, yeah.
3068. Okay, I just want to make sure my math was right. Okay, thank you.
Cool.
306.
So here's where military time comes in. So we're solving for time. All right, so I want to read this question to you. So an IV of 500 milliliters is infusing, meaning it's already going into the patient through gravity, 10 drops a minute. And because it's going through gravity, we have a drop factor of 15. But at 1400, the IV only has 300 milliliters left in the bag. LIB means left in the bag. What time will the IV finish? So it's asking you to solve for time. So where do you think I should start? Do you think I should start with 500 milliliters or should I start with 300 milliliters? Because
300.
the volume is what I need to figure out. When will that volume finish going into the patient? And I heard somebody say it, Diana?
300.
300. Because when I walked in the room at 1400, there was only 300 milliliters in the bag. It's nice to know they started with 500, but what I did when I walked in is I saw 300 milliliters. So I'm going to calculate what I assessed. So I'm going to start with 300 milliliters. So I don't need the 500, and now I've just used the 300. What time will the IV finish? I'm solving time. So the time we're solving for is hours. Okay? So now I have to get rid of milliliters and work my way to hour. What in my problem that is left will get rid of the milliliters?
15
over
1 ml.
Okay, cool. Gets rid of my milliliters, cross it off. What can get rid of my drops?
1 minute on the top over 10 drops.
Minute over 10 drops. Okay,
Mm.
cool. What do I do to change minute to hour?
1 hour over 60 minutes.
Okay. Pretty easy, I think, at this point. It's like, what are you, crazy? You guys are like, she's high. All right. So now we have everything we need to solve for hour. All right. So now when I do the math across the top, it'll give me 4,500 over 600. And when I divide, my calculator will give me 7.5. What the heck does that even mean? Well, now we're dealing with meds and time and military time. So now I need you to think outside the box and open your mind. Okay. Every number before the decimal represents hours. Anything after the decimal represents minutes.
7 hours, 30 minutes.
Okay. 0.5. How do you know 0.5 is 30 minutes?
You multiply it by 60.
All right. Very good. So I know I have 7 hours, but now I have to figure out what the 0.5 is. So for those people who don't know what you should do, you would now take 0.5 and multiply that by 60. And when you do, your calculator will give you 30. Because here's the thought process. I don't know any time that's 0.5. There's no such thing. It represents, let's say, seconds. So there's 60 seconds in a minute. That's why we multiply it by 60. So now I have an IV that will take 7 hours and 30 minutes to infuse. But what did the question ask me?
What time will it finish from
What time am I going
2
back in the
o'clock?
room? That's what I need to know. I need to go know when I'm going back in with a brand new IV.
21:30.
So what do? If I walked in at 1400 and it's going to take 7 hours and 30 minutes to infuse, I need to walk back in at 21:30 to put a brand new bag up. And that's how you solve for military time. So you notice how I wrote 21:30. What time is 21:30?
9:30 p.m.
Yeah. But when you answer your question, you better write military time, because if you write 9:30 p.m., it's wrong. So yes, that would be 21:30. Don't write hours. Military time, you just write 21:30. That's all you write, nothing else.
I have a quick
Nothing
trick for
else.
you guys, Professor.
What's that?
I have a quick trick. First of all, I changed my watch and my phone to military time. I
I
think
always
you
tell
advised us
students
to
that.
do that. But also, if you just -2 from the time you're looking at, it'll give you the number in, I guess, conventional time. I don't know what it's called, but yeah. So like if you -21 with 2, it's gonna give you 9, basically. You know what I mean? Imagine it's 9, but you get what I'm saying. So that's how I remember.
I was never good at military time. Ever.
I had
Me
another
neither.
way. I know 1 o'clock is always 13.
Yeah.
So anything after that, or you minus 12 from whatever the first two numbers are.
Well, that's why we use military time, because if a doctor says give the med at 1 a.m. or 1 p.m., which one? But if the doctor said give the med at 1300, you know when to give it, right? So that's why we use military time. So medication administration records, your timing is based on military time because there's no confusion. There's no confusion. Where the students get these answers wrong is they answer in regular time, or they do this. That's wrong. That's not military time. Military time is just the numbers. That's it. No semicolons. The only time you would use a semicolon if we were counting seconds, and I'm crazy, but I'm not that crazy because I'm the one that has to grade the test. So that is standard military time. No colons, nothing. Just the numbers, okay? And you don't have to write hours or AM or PM. None of that. We know what that is if you're answering for time, okay? So now I'm going to let you do this question. All right, I'm getting good answers. All right. Good. All right, so some of you are off by a couple minutes, and I absolutely know why. So I'm going to show you why. So first off, this is asking me to solve for time, so we're solving for hours. Okay, we know that. Do I start with 1,000 or 550?
550.
I always start with what's left in the bag. So 550 milliliters over 1. So now by process of elimination. So I don't need the 1,000. I walked in at 8 and there was 550 milliliters. Cool. And that's what was left in the bag. So how do I get rid of the milliliters?
25 drops over 1 ml.
Yeah. So you have to know that when it says drop factor or DF25, that means it takes 25 drops to make 1 milliliter. So that's how I would remember it in school. And that would cross off my milliliters to get rid of drops. I'm going to use the 73 drops per minute. That's provided to me. And then minute to hours is 1 hour is 60 minutes. All right, so I'm about to teach you a very important rule when you're doing calculations, and that's only round at the very end of your problem. So when I do all this math, it's like 13,750, I believe, 750. Yeah, and then over 4,380, and when I do the division, my calculator will give me 3.139269. So I know the 3 represents hours, 3 hours. But what does the 0.139269 represent? Well, this is what I mean by you do not round until the very end. You should use all of these numbers and multiply that by 60. And when you do that, it will give you 8.35. So 8.35 is rounded to what? Because now we're solving for minutes.
8 minutes.
8 minutes, all right. So 8 minutes. If you did not use all of these digits, at least 6 of them, after the decimal, you will be off by 1 or 2 minutes every time. All right. So now I'm solving. It takes 3 hours and 8 minutes to run this 550 milliliters. So I walked in at 0800. It's going to take 3 hours and 8 minutes. So what's my final answer? 1108. So if you got 1106, I will make it a rounding error if I see that you didn't use enough numbers or digits to multiply. So that's the lesson, is never shorten these decimals to the point beyond 6 numbers, because you need to use them for your final answer. Okay?
Professor.
Yes.
So,
Hmm.
I guess after we did the math at the top, you're supposed to separate the whole number as a 3 and then multiply 60 minutes as a remainder?
Yes. So
Yeah, I
good
definitely
question.
would have
Hold on.
got the 5 points
So
missing off of this.
it's 3.139269, right? When you did your division right here,
Right.
if you divided 4,380 into 13,750, it will give you 3.139269 on your calculator. You need to know that any number before the decimal is always hours.
An hour.
Anything after the decimal represents minutes, but we have to use that decimal. So it would be 0.139269 times 60. So put that in your calculator, 0.139269, and multiply it by 60. And that will give you 8.35.
8.35.
And we would round that to 8 minutes. So it's 3 hours and 8 minutes.
Gotcha.
Yeah. All right. Tell me what the answer to this question is. And I'll be able to identify all of my overthinkers immediately. Okay. Okay. I'm getting all the answers I suspected. So how do what am I asking you here? And why am I asking? It's like seems so simple and so easy, right? Oh, that's the wrong unit of measure though. I just saw. Well, that would have been 5.5.
You're asking, you said the patient had 4 injections today.
Mhm.
Each one was 0.345 milligrams. What was the total amount of medication the patient received for the day? So it would be the total milligrams of medication that the patient received for the day. So you're going to say he got that 4 times. So it would be 0. Time, right, and the answer is 1.38 milligrams. So will we round that to 1.4 milligrams?
Yes, you would. And that's what
Okay.
I'm testing. Very good. So I need to know that you can look at this and say, all right, they got 0.345 milligrams. I gave him 4 shots. And the doctor says, what, how much total did he get today? What's going on? Let's say if it was morphine, I don't know. You would say he got 1.4 milligrams, doctor. It's as simple as that. But I'm testing your knowledge to something so basic. Can you step back and still follow the same steps, follow the rounding rules, and then use the correct unit of measure? And that's all that is testing you. Nothing kooky. So this one, 3.35 times 3, your answer will be 10.05 milligrams. And then you need to go 10.05. What's my final answer?
10
10
milligrams.
10
more.
milligrams. It's not a trick. That's it. That is it. All right. So if you come across one of those, that's all that it's testing. Your ability to take it back and look and say, oh, okay, something so basic. Because we're used to running at this high function, and then all of a sudden we're hit with this, and then you're like, you all of a sudden forgot to add and subtract. Now there's one problem we didn't get to today. I just gotta locate it. That I will show you. I just gotta find it. It's solving for micrograms per kilogram per minute. And I appreciate you all staying around and hanging out with me. I'm sure you had nothing better to do.
I think we appreciate you staying around and not chopping
Yes,
us
I
off.
agree. We
I think
appreciate
I
you.
think we want I
Thank
think
you.
we wanted a little bit more of this. So we
Absolutely.
appreciate
If
you.
you free this weekend, let me know.
Oh,
That
okay.
right? You know what I'm saying? This is what I'm talking
She's
about.
like, I'm coming over
I'm
your
trying to
house,
figure out the
Professor.
Zoom. It
I
works better
cooks,
when you
if you
talking it
free.
over.
Yeah. Yeah. I'm trying to find an example. Oh my goodness. And it's you've had it available to you. I just like to go over it real quick, but I always forget to add it, and I don't know why. Now, undoubtedly, you will all freak out when these questions are presented to you while you're sitting there because your anxiety will definitely take over. It's natural. Just take some deep breaths and try to remember all the hard work you've been putting in. And listen, worst case scenario, if it don't work out, so what? You hang out with me, right? It could be worse. Why can't I find an example? I can't find it. Oh, someone's coming in late. Oh my goodness. Oh, there's one. Okay. So the last problem I want to show you is this one. And this one is telling you to solve for how many micrograms per kilogram per minute. So now you're solving for 3-factor. And this is like high level critical care meds, just like the order when it was written like this. Now we're solving for this. So where do I start? I know where I'm going, but out of everything that's available to you, if you were looking at this, where do you think I would start my problem?
I think I would start it with the medication I have on hand.
Okay. And you wouldn't be wrong.
250
Yeah, you wouldn't be wrong there.
milligrams per.
Right. And you wouldn't be wrong if you started with the volume over time, because I always go, when in doubt, volume over time. And because
Okay.
I start volume over time because it has time in the denominator and I need time in the denominator here. So that's how my process is. But you can start either way. You just got to make sure you set it up properly. So if I'm starting with volume over time, I only have certain things left in my problem. So you know this is going to be heavy on a lot of conversions. So I'm actually going to shrink this because it gets really ridiculous, but I want to show you that you could do it if you follow just remembering what you know. So start simple. How do I get rid of hours and change it to minute? The same way. 1 hour is 60 minutes. Cool. But I need a kilogram here. You see how I need kilogram? It wants me to use a kilogram in the denominator. But I only have a patient weight. So this is what I call nurse math. If you ask, I shall give. You want it? I'm giving it to you. I'm putting a kilogram here. And 1 kilogram is 2.2 pounds. You want a kilogram? I'm giving you the kilogram. And that's what I call nurse math. We do what we want. So now I have to get rid of the pounds. So how do I get rid of the pounds?
130 at the bottom.
Right. So now it doesn't feel right to us because we've been practicing it with 130 on the top. But I'm doing what you need to do to solve. So I'm putting 130 on the bottom and I'm putting a 1 on top. And I'm crossing off those pounds. So now my denominator is done. Now I got to work on the top. I have a milliliter and I need micrograms. The only thing left in my problem is this concentration. So I'm going to put 250 milligrams over 500 milliliters because that will cross off my milliliters. Now I have used everything in my problem and I've added a kilogram. But now I have milligrams and I need micrograms. So you know what to do. What is it?
1 milligram over 1,000
That's it.
micrograms.
1 milligram is 1,000 micrograms. And you have just set up your problem. It's a disgustingly long problem, but you just set up. When you are finished solving this high level type of problem, you will end up with how many micrograms per kilogram that patient is receiving per minute based on how fast that IV is going. And that's pretty incredible stuff. So I like to cross off the zeros, 1, 2, 3, 1, 2, 3. So let's do the math together because I don't have the answer to this. 55 times 2.2 times 250 equals 30,250 over 60 times 13 times 5 equals 3900. And now I'm going to divide. And it's going to give me 7.7564102. So what do you think my final answer is?
8.
I heard 8. Any number between 1 and 10, we round to the tenths.
7.8.
I look to the right, it's 5 and up. I'm going to change the 7 to an 8. So 7.8 micrograms per kilogram per minute. Welcome to critical care. Boom. That's juicy, right?
Yep, it sure is.
That sure is. So find one of these problems in all the sheets, practice it. Remember, this is the one where you get to do nurse math. And again, please, if you are not successful, do not get discouraged. You just crammed 14 weeks into 2 weeks. All right. And you're doing your best to prepare. But worst case scenario, you just get to hang out with me and take the live class. Come in person if you have to. Any other questions?
No, this was great though.
I'm glad you stuck around.
For the actual test itself, like the formatting of it, is it how many questions is it? I know you said we get an hour, right?
Yep, there's 20 questions.
Okay.
And the first page will be, oops, not that. The first page looks like it's just the oh gosh. The first page is the directions with the rounding rules. And then the second page will literally be it's like 2 questions on each page, but it's 20 questions.
Okay.
And each question is 5 points.
Uh-huh.
And if it's a rounding error, and I can tell from your work that it's a rounding error, it's only 1 point off. But you can find out all the details in this right here directions.
1 hour.
Gotcha. And the finger stick calculations, will that be included on the test, or is that something we have to memorize?
If I looked over it, what do you mean the finger stick calculations? You mean insulin?
Yes, insulin.
If I went over it, I would definitely be familiar with it.
Okay, because I didn't know because you put it there. I wasn't sure if that was something that would be on the test. Like,
yeah, just knowing the insulin orders and stuff and how to read them.
Oh, not that. The like if you scroll up a little bit, I think it was there. Where is it? Or maybe not.
I think
It
she
was
means like the less than 200, you give nothing.
Oh,
Okay.
that'll be
The sliding scale, that's coverage.
Oh,
Yes.
it'll be put on there.
Coverage.
If there's coverage, it'll be provided for you in the question.
Okay, just wanted to make sure. Thank you.
Yeah, no. If there's a coverage order, you will see something very familiar. Yeah, you should definitely be familiar with that.
Okay.
You don't have to memorize the scale though.
Okay, that's what I was wondering.
Oh, okay. I was wondering. Yeah, no, you don't, the scales are different for every patient. Some patients who are brittle diabetics may have different variables. So no, we provide the scale. You don't have to memorize the scale.
Okay, thank you. And you said just to email you in regards to getting all this information, because I think maybe it was provided on the information session.
It was, but if you can't find that sheet, I will wait a few minutes after and I'll send it to you. Just email me now.
Perfect. Yeah, I'll do that now. Thank you.
Will this recording be available for us to rewatch it?
Yeah, provided it actually records because it kept shutting off and pausing. I don't know what's going on. But I will once this is over, I will what I do is I hit save and then I have to wait for Zoom to post it. And if it is posted, I will definitely put it in the YouTube channel.